Hi everyone. Welcome to all of you on my YouTube channel. So those who have not subscribed the channel, just go and subscribe the channel, and as well as you can share in your group also. So those who are not getting benefit of getting a study of all of these free things, they can get benefited. So this PYQ series is completely based on how much maximum output can be extracted from the GATE previous year paper only. So I'm thinking to upload all of these video of PYQ for all of these subject, but let's see how up to what time or up to how many subject I can upload. Okay, so let's start with this question first. So this question says a liquid is flowing through a reactor at a constant flow rate, right? A stepped input of tracer at a molar flow rate. So molar flow rate is given to you here. So Fa naught is equals to 1 mole per minute at t equals to 0. When time t is equals to 0, this step tracer input is given to the system, and the time variations of the concentration of tracer at the exit of the reactor is given to you. So you can see this curve is given to you. So I am also drawing in magnified way. So this one is concentration, which is in mole per liter, and versus time. So since this is a step tracer input experiment, so you can see this will go something like that, and after that this is going like that, this is going like that. So whenever you see this t is equals to 5, t is equals to 1, this time is 1 and this time is 0 here, and the maximum concentration of tracer, that is 1, that is your C node, right? So whenever there is a step tracer input experiments, you can see that this will be C node, that is equals to C max. This is very important. Now you are supposed to calculate the volumetric flow rate of the liquid through the reactor. So molar flow rate Fa naught is given to you, what? 1 mole per minute, and you are supposed to calculate the volumetric flow rate in liter per minute. So what is Fa naught? Fa naught is equals to Ca naught multiplied with V naught. So Fa naught is 1 mole per minute, that is equals to Ca naught. Ca naught is how much? 1 mole per liter multiplied with V naught. So you can see that V naught is equals to 1 liter per minute. So this volumetric flow rate you have got is 1 liter per minute, and based on this your option A will be your correct option. Now you are supposed to calculate from in question 5.9 the mean residence time of the fluid in the reactor. So when we talk about the mean residence time for this particular problem, so you can write C max multiplied with T bar, that is equals to area under T and C curve. So what is the area under T and C curve? So C max multiplied with T bar, that is equals to which area you have to calculate here? You are supposed to calculate this area. This area. Is that clear? So whenever we have a step tracer input, you have to assume this one is the area on CT axis versus time. So this area can be calculated as, that is 1 upon 2 multiplied with, this is trapezium. So 5 and 1 into 1. So 5 plus 1 multiplied with 1. So C max is 1, that is C node. 1 multiplied with T bar, that is equals to 1 by 2 multiplied with 6, that is 3. The mean residence time T bar is equals to 3 minutes. This is as simple as that. This is very, very simple question, but here the difference between another problem and this problem is that whenever we are writing these things, you have to understand this particular line. This is the concept here. So you should keep these things in your mind whenever you are writing the paper, right? Okay, after that I'll be moving towards the next question of today's discussion, and this question is from isothermal pulse tracer test is conducted on a reactor, and the variations of outlet tracer concentration with time is shown in the figure. So here you can see the variation in the outlet concentration of the tracer is given to you. So this one is the tracer concentration. So let's say this is concentration in mole per meter cube, and this one is the time in minute. So this tracer experiment shows this curve, something like that. Okay, so here this one is 0, this one is 5, this one is 10. So on x-axis there is a time in a minute, and y-axis concentration in mole per meter cube. So you are supposed to calculate the mean residence time. So when we talk about mean residence time, that is equals to 0 to infinity t into Ct dt divided by 0 to infinity Ct dt. So when we talk about here for this particular curve, just try to understand when time is less than 5, when time is less than 5, concentration is 0. When 0 is less than, time is less than, when time is between 5 to 10, so concentration is a what, how much? So this is 10, so that is 10. And when time is greater than 10, again concentration is 0. So if I want to calculate 0 to infinity t into ct dt, so I can write 0 to 5 into 0 dt plus integral 5 to 10 and t multiplied with 10 dt plus integral 10 to infinity 0 dt, right? So ultimately you will see that only 10 t square divided by 2, and it will go from 5 to 10, that is equals to 10 multiplied with 100 minus 25 divided by 2, that is equals to 10 multiplied with 75 divided by 2, so that is 37.5 multiplied with 10, that is equals to 375. So the numerator you have already calculated. So what is denominator? Denominator is the area under the curve, CT versus T curve. So you have to calculate this area here. It's very, very important thing that you should know. So what is area here? Area is, this is rectangle, so area is 5 multiplied with 10, that is equals to 50. So you have calculated denominator is 50 and numerator is 375. So what is mean residence time here? So you can calculate the mean residence time, that is equals to 375 divided by 50. So I think that will be equals to, that is 7.5 minutes, I think. Yeah, so that is 7.5 minutes. Your option B will be your correct option, right? This is very simple thing, but again you have to remember this formula, right? You remember this formula, then these things is very easy for you. Okay, so I'll be moving towards the next problem. So here two reactors, reactor 1 and reactor 2 with average residence time. So reactor 1 is having residence time is tau 1, reactor 2 is having residence time is tau 2, are placed in series. So this reactor is placed in reactor 1 has a 0 dispersion and reactor 2 has infinite dispersion. So whenever there is a 0 dispersion, that reactor will be called as the PFR, and whenever there is infinite dispersion, that reactor is called as CSTR. So PFR is having 0 dispersion and CSTR is having so you should know these things, right? So now you get to know that there is a PFR is connected in CSTR in series, right? So these things is happening here. So having residence time is tau 1 and having residence time is tau 2, and the residence time distribution of the system is given to you. So when we talk about the residence time distribution for this particular thing, so you can say that ET curve can be written as 0 when t is less than tau 1, and that is equals to 1 by tau 2 exponential minus t minus tau p divided by tau m when t is greater than tau 1, right? So since I am assuming tau 1 is the t minus tau 1 divided by tau 2. So tau 1 is the residence time for the plug flow reactor and tau 2 is the residence time for the continuous stir tank reactor. So based on this particular thing, you can select your option. So your option 1 by tau 2, 1 minus exponential minus t minus tau 1 by tau 2, t is greater than tau 1. So based on this, your option A will be your correct answer. So this is just a formula based question. You don't have to do anything, but if you remember the formula, then definitely you will be able to do. But based on the formula also, sometimes let's say in future they can ask you questions on your numerical things, right? Also, so you should understand this thing. Okay, now moving towards the next question, that is 5.12. So these three curves, figure 1, figure 2, figure 3 have been given to you. So you have to match the column. So figure 1 shows which, so okay, so again if you see these things, pulse tracer input is given to you. So whenever we see this kind of curve in pulse tracer input, repeatedly I am telling you these things. So whenever we see this concentration versus time curve and this curve is like that, So this curve shows that Ct, that is equals to C naught into e to the power minus t by tau m, and this is for CSTR, for pulse input. Now when we talk about this kind of curve, when we see this curve, concentration versus time curve, and if it is looking like that, and there is a this things hump in there, so again you can see this kind of plot can arises only when there is a CSTR and when there is a PFR in parallel combination, right? Why? Because continuously from CSTR you are getting Ct is equals to C naught into e to the power minus t by tau, and whenever there is a output, the output will come from, or the concentration will come from PFR, again it will shoot out, something like that. So that's why here it is showing there is a shooting out of this particular thing. So shoot out says that there is a PFR and this PFR is there in the parallel combination, something like that. So eventually concentration, you will see your concentration will shoot out at a particular time, and again it will start dropping, right? Because this is a PFR, something like that. So this shows the CSTR and PFR in parallel condition. And again figure 3rd, repeatedly I have solved lots of question on this. So you can see this is for CSTR and PFR in series, CSTR and PFR in series, something like that. So figure 1 shows that CSTR only, so your option P is your 2. Figure 2 shows PFR and CSTR in parallel, so option Q is your 4, and option R figure 3, PFI and R and CSTR in series combination, so 3. So 2, 4, 3 is your correct option. Is that correct? 2, 4, 3 is your correct option. Okay, this one is the. So this is how you can logically solve this kind of question. This kind of question is very, very important. Very frequently you can see the repeated concepts are coming. So maybe in future all of these concepts will be there in the problem, but you have to understand which kind of concepts are there in the problem. Okay? Now moving towards the next question. Again, this question is also very, very important, asked in 2013. This question says the exit as distribution for a reactor is given by ET. So your ET is given to you del T minus 4, where T is in second. A first order liquid phase reaction is there and having rate constant is 0.25 second inverse, is carried out under the steady state condition, isothermal condition. The mean conversion of the reactant at the exit. So whenever we talk about the mean conversion, so you have to use the segregation model. So what segregation model says? Segregation model says x bar is equals to obviously 0 to infinity and your xt et dt, right? This one is the formula for mean conversion from the segregation model. So x bar is your mean conversion. So whenever we talk about the first order reaction, for first order reaction, what is xt? Xt is equals to 1 minus e to the power minus kt. And what is k? K is given to you, so you can calculate xt is equals to 1 minus e to the power minus t by 4. So we have calculated the value of xt. Now let's move towards the mean conversion value. X bar will be written as 0 to infinity and xt 1 minus e to the power minus t by 4. And what is et? So et is your del t minus 4 dt. Now here comes the concept of direct delta function. So whenever there is direct delta function, and if let's say this time is there, and if this time is in between limit of integration between 0 to t, so you can say that 0 is less than 4 is less than infinity, right? So what will happen? Integral 0 to infinity ft into del t minus a, let's say del t minus a, that will be equals to only fa if this is integrated in this limit, right? Or when 0 is less than a is less than infinity. Is that clear? And if this a is not going to lie between, if a is not going to lie between 0 to infinity, then that will be value will be equals to 0 when a is not lying in this particular range, right? So if 0 is not something like that. Okay, so that's why this is the function ft and this is the value of a. So directly we can write what the mean conversion f x bar, that is equals to 1 minus e to the power minus 4 divided by 4, that is 1 minus e to the power minus 1, that is 1 minus 1 by e. Is that clear? 1 minus 1 by e, something like that. So you can calculate this value now. So this is how you can solve this kind of problem. So the most important concept here was Dirac delta functions concept. So whenever we are integrating any limit, let's say 0 to t, or let's say if I am doing a to b, and let's say ft into del t minus p dt, that will be equals to fp when a is less than p is less than b, that is equals to 0 when a is not under between p is not under between b, something like that. Okay, so this question was only based on this. So you should know this concept as well as the segregation models mean conversion concept also. That's all. I hope this things is clear to all of you now. After that, I'll be moving towards the next problem. The impulse response to a tracer. Impulse means pulse response to a tracer pulse experiment for a flow reactor is given below. So you have been given, there is a curve that is there, something like that. Sorry for that. This goes like that, this comes like that. Okay, so this is 0, and at this point this is 2, and this one is the 4. So this one is the concentration versus time. So in the above, C exit is distribution corresponding to E to E theta curve is correctly represented by which of the following. So okay, so whenever concentration curve is given to you, how to convert this CT curve to ET curve, CT to ET curve, right? So whenever you divide the area of CT curve, that will give you the ET curve. So what is the area? You have to calculate this area. So what is the area of this curve? So area will be equals to 1 by 2 into base is your 4 into height is your 5, right? So area is 10. So if I divide the curve with area 10, so what will happen? So this is the maximum value, which is your 5. So whenever I'll divide these things, you will see this graph will, just this is a shifting of graph, that's it. So y coordinate of graph will be getting changed only, that's it. So it will be looking like that only, that's it. And this value get divided by 5. So here it will be 0.5 only, and again that is 0. This will be 2 and this will be 4. So now this is your ET curve. So you can see that there is a 0.5 versus this. So option C will be your correct answer. Option C will be your correct answer. Is that clear? So you have to divide, because what is ET? So just you have to divide the these things by whole area. So that is the value of exit distribution function can be written as integral 0 to t or 0 to infinity t into ct dt divided by 0 to infinity ct dt, right? Sorry. So obviously ct divided by 0 to infinity. Again I'll write these things. So the value of ET will be equals to ct divided by 0 to infinity integral ct dt. So this integral ct dt is called as the area under t versus ct curve, something like that. Sorry, ct versus t curve, actually ct versus t curve, something like that. Okay, I hope this question is clear to all of you now. I'll be moving towards the next problem of today's discussion. This question is also from a CSTR. So a CSTR has a long inlet pipe. So whenever we talk about long inlet pipe, that means it indicates that you have a CSTR, and then this CSTR is connected with a long inlet pipe, means This will be modeled as a plug flow reactor is in the downstream upstream direction of CSTR. The E curve obtained at the exit of CSTR is given to you. So the E curve is given like that. Exit edge distribution curve is given to you, something like that. This is going like that. This is time, and this one is the ET versus time curve, and this value at this maximum it is showing 0.05, and this one is the 5. Among the ratio of the volume of pipe to the volume of CSTR. So let's say volume of pipe is volume of plug flow reactor, volume of CSTR is volume of mixed flow reactor. So you are supposed to calculate Vp divided by Vm. That can be written as what? So if I write tau is equals to Vp, tau p is equals to Vp divided by V naught. So tau is directly proportional to volume, so it can be written as also tau p divided by tau m. So this is the concept that is hidden in this particular problem. Once you understood this thing, then definitely the question is very easy. Now just try to understand what is tau p. So tau p is obviously, since PFR is connected in CSTR, so that value will be tau p. And when we see this particular curve, so this curve shows 1 upon tau m and e to the power minus t minus tau p divided by tau m. Is that clear? So when t is equals to 0, what will happen? When t is equals to 0 at this point of time, or sorry, what is the concentration here when t is equals to tau p? So 1 by tau m. So this particular in value indicates here, this particular value will give you that 1 by tau m, right? So what is 1 by tau m? 1 by tau m is equals to 0.05. So what is tau m? Tau m is equals to 100 divided by 5, that is equals to 20. So you get to know the tau p. Tau p is known to you. Tau p is equals to 5. So what is Vp divided by Vm now? So you can calculate Vp divided by Vm, that is equals to tau p divided by tau m, that is 5 divided by 20, which is 1 by 4, 0.25. This will be your answer. So I mean, again, you can see repeatedly the questions are coming from CSTR is connected with PFR, and sometimes they are giving in terms of concentration, sometimes they are giving in terms of exit edge distribution function with time. So the formula is more and less same, but you have to understand again if you know the formula, let's say CT PFR is connected in CSTR or pulse tracer input, that is equals to C naught into e to the power minus t minus tau p and divided by tau m. So the exit edge distribution function can be written as what? Ct divided by 0 to infinity integral Ct dt. And once you do the integration, so this is Ct, and once you will substitute these things, directly you will be getting 1 upon tau m e to the power minus t minus tau p and divided by tau m, something like that. So again you can also calculate what is Ft. Ft is equals to again 0 to t and obviously et dt, something. So any kind of things that can be asked. So till now they have not asked questions from Ft, so there is high probability that the questions based on the Ft can be asked. So you should be prepared with these things, something like that. Okay, so if it is clear, then I'll be moving towards the next problem of today's discussion. The question 5.17 shows the curve measures during the pulse tracer experiment is shown below in the figure CT. So you have a curve of pulse tracer experiments. So again pulse tracer experiments are there, and this curve is between CT versus time, and this curve looks like that. There is a triangular kind of shape. Okay, so this midpoint is 1, this one is 2, and here you can see the mean residence time in the reactor. You are supposed to calculate the mean residence time. Okay, so just try to understand. So what is mean residence time here? So the mean residence time can be written as integral 0 to infinity t into Ct dt divided by integral 0 to infinity Ct dt, right? So the parts which is the thing that is there in the denominator, or the parameters which is there in the denominator, that is the area under Ct versus time curve. So what is the area here? So this point is maximum and this is 1. So the area will be equals to half into base into height. So area is 1, right? So if area is 1, then what is time? T bar will be equals to 0 to infinity and t Ct dt. Now you have to understand what is the equation of this line and what is equation of this line. So Ct is having two parts. When Ct will be equals to when time is less than 1 and when time is greater than 1. So when time is less than 1, what is the equation, and when time is greater than 1, what is the equation? Just try to understand one thing. So let's say if any line is passing through point, this equation, what is the coordinate of this point? That is 1 and 1, and the coordinate of this point is 0, 0 and 0. So Ct is equals to t when t is less than 1, and if I say that Ct is equals to t minus 2, so if I'll substitute t is equals to 1, so that value is equals to, sorry, Ct will be equals to 2 minus t. So here when t is equals to 0, 2, when t is equals to 1, that is 1. Okay, so this equation we get to know Ct for Ct. So now we can substitute this value here, that 0 to 1 t into t dt plus 1 to 2 2 minus t into t dt. So sometimes you need to calculate the equation of this line, right? That is very important only. So only this part, once you get to know the equation of this line, because this is a straight line only, that's it. You can do anything, these things, because you would have studied in your class 12 also. So now you can get 0 to t square dt plus integral 0 to 1 and 1 to 2 2t minus t square dt. So the value of t bar can be written as obviously tq by 3 0 to 1 plus t square minus tq by 3, and this value will be 1 to 2. So this is just a simple integration. Now you don't have to do anything. That is your 1 by 3 plus 4 minus 1 minus 8 minus 1 divided by 3. So now the value of t bar can be written as 1 by 3 plus 3 minus 7 by 3. Is that clear? So that is equals to 3 minus 6 by 3. So that is to 1. So the mean residence time you will be getting is 1. Is that clear? And if you want to do with the shortcut, so what you have to do, you have to take these things. If the graph is symmetric, so you have to add all of these 3 points, 1, 2, 3. So 0 plus 1 plus 2 divided by 3, that is equals to t bar. So the value of t bar you will be getting is 1, something like that. So this shortcuts is only applicable when there is a symmetric curve. If the curve is not symmetric, then you cannot use this kind of things, right? Okay. So after that, I'll be moving towards the next problem. This question is asked in 2019 by IIT Madras. This question is really important. But here you can see, again, this question is very similar to the earlier question, but you have to understand, let's say a reaction 2A is getting converted into D. So parallel reaction is occurring, having rate constant is K1 and K2. And reversible liquid phase reaction is acting in a non-ideal reaction. The curve measured in the tracer experiment. So here you can see the concentration versus time curve has been given to you, right? Again, so let's say this one is concentration versus time curve, and this curve goes like that, something. Okay, and at this particular point you will see this one is 1, and this value have been given to you, that is the 5. And 0 to 1, and this value is 6. The rate constant are, so here you can see K1 is given to you 0.2 liter per mole minute, and again K2 is given to you 0.3 liter per mole minute. So I think this one is the second order reaction, right? So this, both of these reaction is n equals to 2 and n equals to 2, second order reaction. Okay. So pure A is fed to the reactor, and concentration is given to you. CA0 is your 2 mole per liter is given to you. And using the segregation model, you are supposed to calculate the percentage conversion. So you have to calculate the percentage conversion in percentage, x bar in percentage only. So there may be fraction conversion, there may be percentage conversion, but here you are supposed to calculate in percentage conversion. So first try to understand, when we talk about the segregation model, so average conversion can be written as 0 to infinity, and again xt into et dt. So first you have to calculate xt, then you have to calculate et, and after that you can calculate the conversion, mean conversion. So what is xt? So since this reaction is a second order reaction, so can I write minus dCA by dt, that is equals to k1 Ca square plus k2 Ca square. Since this is parallel reaction, so I'm not going to solve all of these things, but you have to understand. So minus dCA by dt can be written as k1 plus k2 Ca square. So now you can substitute Ca equals to Ca naught into 1 minus Xa, and directly you can get the value of xt. I'm directly writing xt is equals to your k1 plus k2 into Ca naught t divided by 1 plus k1 plus k2 into Ca naught t. So what is the value of k1 plus k2 here? K1 plus k2 will be 0.5. So now the value of xt can be written as 0.5 is half, so Ca naught t divided by 2 plus 1 plus Ca naught t divided by 2. So directly I am writing this value of xt, that is equals to Ca naught t divided by 2 plus Ca naught t, and the Ca naught is given to you is 2 moles, right? So now you can write xt will be equals to 2t divided by 2 plus 2t, that is equals to t upon 1 plus t. So xt you have calculated. Now next thing is that you have to calculate the ET value. So for ET value, what is ET? So ET is equals to 0 to infinity. ET is CT divided by 0 to infinity, and obviously area under the curve CT dt. So what is the area under the curve? So the area under the curve you can calculate here. Area is half multiplied with base is 6 and height is 5, so that is equals to 15. So if I calculate area under the curve is 15, already we have calculated these things, area. So what is the equation of this point? So I mean this line. So let's say if I am assuming this one is line 1 and this one is line 2. So the CT value, the equation of CT will be in two parts, when t is less than 1 and when 1 is less than t is less than 6, and 1 when t is greater than 6. 3 parts. So what is the line of equation of this line L1? So this point will be your what? 1 and 5. So slope is what? 5 by 1. So this line slope is 5. So this line will be your 5t. Right. And what is the slope of this line? So this slope of this line is y by x. So y is 5 and x is 5. So slope is 1. So here you can say that 6 minus slope is also 1. So here the line's equation is 6 minus t. Yeah, 6 minus t. Okay, when t, yeah, and here it is 0. So you have calculated the equation of this line. This line's equation is very, very important. This line's equation is very, very important. After doing these things, now we can directly substitute this value over here. So that's it. So if I'll substitute this value, so x bar will be equals to, I'll go from 0 to 1, and ct, so I can write xt is your t upon 1 plus t, and again et. Now before that I have to calculate et. So what is et then? Et will be equals to, again it will get divided by area under the curve 15, so that is equals to t by 3 when t is less than 1, and 6 minus t divided by 15 when 1 is less than t is less than 6, and 0 when t is greater than 6, something like that. So we have et, we have xt. So now x bar can be written as t upon 1 plus t multiplied with et is t by 3, and this is 0 to 1, plus again it will go from 1 to 6 minus t divided by 15, and again this is t upon 1 plus t dt. So this will give you the overall conversion using the segregation model. Is that clear? These things are very important, but again this question is really complicated. 2 marks question is there, but it is taking lots of time. But again, whether you are comfortable with this kind of questions or not, concept you know, but if you are able to solve this question very fast, then definitely the question will be very easy. And but again, you have to understand how to solve this kind of problem. Okay, but this was the method that first you have to understand this particular formula, and once you know this formula, you will have to calculate xt and et, and then you have to do the integration only. That's it. So you have to be very fast for this particular problem. Okay, now I'll be moving towards the next question, that is 5.20. This question says that an elementary irreversible liquid phase reaction, which is 2p, is getting converted into q having rate constant is k, where the rate constant k is given to you, that is 2 liter per mole and per minute, takes place in isothermal non-ideal reactor. The E curve in the tracer experiments is given to you. So this E curve is given to you. This one is your ET versus time curve, and this looks like in this way. Okay, this value is 0.5. Pure A having 2 mole per liter, so the concentration of pure A, Ca naught, is equals to 2 mole per liter is given to you, is fed to the reactor. Using the segregation model, the percentage conversion, again the same question is there. So you have to calculate the mean conversion x bar using segregation model. So that is 0 to infinity, using segregation model 0 to infinity, and obviously xt into et dt. That's it. But this problem is not very difficult like last problem. So here you can see the equation. This equation is very easy. So you have to calculate the equation of this line only, right? So if I calculate this slope, and first thing, second thing is that in order to calculate the equation or write the equation of this line, you know this value is given to you, and you are supposed to calculate the coordinate of this point. So the coordinate, x coordinate of this point is given is 0.5, but you don't know y coordinate. So y coordinate is very important. So how to calculate the y coordinate? So area under ET versus time curve used to be 1, that you know these things. So the whole area, let's say this area will be 1. So area will be 1, that is equals to 1 upon 2 into, so if I assume this is trapezium, so that can be written as 1 plus, let's say this value is, let's say I am assuming is x, 1 plus x multiplied with 0.5. So the area is 1, so 4 will be equals to 1 plus x, so the value of x will be equals to 3. So the coordinate of this point is x equals to 3, something like that. So here I can write x will be equals to 3. So the coordinate you got 0.53 and 1, 0 and 1. So what is the slope of this line? Slope of this line will be equals to 3 minus 1 divided by 0.5. So that is equals to 4. So what is the equation of line? That is equals to equation of line 1. Line's equation is 4t plus 1, right? So if t is 0 and if yeah, 40 plus 1. So you know that ET curve is equals to 40 plus 1 when 0 is less than, t is less than 0.5, and 0 when t is greater than 0.5. Okay, now it's very easy, you can calculate the conversion, but again you have to understand this reaction is also a second order reaction. So you have to write what is xt. Xt is equals to k Ca naught t divided by 1 plus k Ca naught t. So what is k? K is given to you, that is 2, and again inlet concentration is given to you, that is 2, multiplied with t upon 1 plus 2 into t, that is 4t divided by 1 plus 4t. So now you got the value of xt. So directly now you'll move forward for the overall conversion, that is equals to 0 to 0.5. xt is your 40 upon 1 plus 4t multiplied with what is et? Et is also 1 plus 4t dt. So if you'll see, this will get cancelled out. So this question is getting simplified now, that is xt is equals to 0 to 0.5 4t dt, that is 4 into t square divided by 2, that is 0 to half. So that is 4 multiply 4 by 2 is 2 multiplied with 1 by 4, that is 1 by 2. So your 50% conversion is there, means 0.5. So x bar will be equals to your 50%. Okay, so you are supposed to calculate the percentage conversion in round of the error. That's why this will be your 50%. Okay, I hope this question is clear to all of you. Now I'll be moving towards the next problem, and this one is the last problem of this non-ideal reactors, and after that I'll be able to complete this PYQ series of non-ideal reactors. So here you can see that a liquid phase second order reaction is happening. A is getting converted into B having rate constant K, and the K is given to you 0.2 liter per mole minute, is carried out in an isothermal non-ideal reactor. A tracer experiments conducted on this reactor resulted in a residence time distribution curve. So you have been given a residence time distribution curve, ET versus T curve, or exit distribution curve also. So ET versus T curve is given to you, and this curve is like that. So this curve will go like that. Okay, this curve is looking like that. So this point is 10, this is 15, and this is 5, right? So let's say model these things like that also, something like that. So you can see here this one is given first, this one is second, and this one is third. So okay, so whenever first you are supposed to calculate the percentage conversion of A at the exit of the reactor. So using the segregation model, and you are also supposed to calculate the percentage conversion X percentage. So same kind of problem is there, but again first you have to understand the equations line. So if I am talking about x bar, that is equals to 0 to infinity, and obviously xt and et dt. So xt, you know, xt into et dt. So what is xt? Xt is equals to obviously k CnOT upon 1 plus k CnOT for your second order reaction. So xt you can calculate, k is given to you, k is 0.2, and CnOT is also given to you 1.5. So 2 into 1.5 into t divided by 1 plus 2 into 1.5 into t, that can be equals to 3t divided by 1 plus 3t. So you have xt value. Now next thing is that you have to calculate the value of et. So et value will be equals to 0 when 0 is less than t is less than 5, and there is some value here. So 5 is less than t is less than 10, 10 is less than t is less than 15, and when t is greater than 15. So 4 et's value will be there. So when we talk about et, so this is constant value, this is also a constant value, only these two value I have to calculate. So how can we calculate these things? So let's say if I am assuming this length is x, so this length will be also x, and this is rectangle, so this value is 5, this value is 5. So if I calculate the whole area, and whole area under et versus t curve will be equals to 1. So what is area? Area will be equals to 3 multiplied with 5 multiplied with x. Why? If I calculate the area of one rectangle and I multiplied with 3, this will give the area of 3 rectangle, and the 3 rectangles area will be equals to 1, something like that. Okay, so now area is 1, that is equals to 15x. So what is x? X is equals to 1 by 15. So this value is 1 by 15. If this is 1 by 15, this is half of 1 by 15, that is 1 by 30. So what is the line of this equation? That is equals to, this constant is 1 by 15, and this equation is 1 by 30. That's it. So this is 1 by 15, and this is 1 by 30, and this is 0. So now you have value of et equations, and you can calculate now. The overall conversion can be written as 0 to 5, 1 by 15 multiplied with 3t upon 1 plus 3t dt, plus 5 to 10, 1 by 30 into 3t upon 1 plus 3t plus 0, all of these things. So only two values you have to calculate. Now this is just a simple integration. So x bar can be written as, let's say if I want to integrate these things, so simply if I want to integrate integral 0 to t or 3t divided by 1 plus 3t dt. So I'll let z is equals to 1 plus 3t. So dz is equals to 3 dt. So dt is equals to dz by 3. So I'll substitute here. So that can be written as 0 to t. And what is 3t? 3t is z minus 1 divided by z. And what is dt? Dt is equals to dz by 3. So that is equals to 1 by 3 integral 0 to t 1 minus 1 by z dz. That is equals to 1 by 3 into z minus ln z. And now I'll substitute 1 by 3 and z is equals to 1 plus 3t minus ln 1 plus 3t. And now you'll substitute 0 to 5. So ultimately you have this kind of integration, right? 1 by 3t. So I'll substitute this value. So the value of x bar is 1 by 15 and directly 1 by 3 and 1 plus 3t minus ln 1 plus 3t, and this is 0 to 5 plus 1 by 30 and 1 by 3 multiplied with 1 plus 3t minus ln 1 plus 3t, and this will go from 5 to 10. That's it. Is that clear? And once you solve these things, you will be getting your answer, and you have to calculate in percentage conversion. So I think they are asked you to calculate percentage conversion also. So here you can write the percentage conversion. But again, I am telling you, the fundamental things are similar. The previous questions were also similar. This question is also similar. Only they are changing the value of ET curve. And very frequently you can see in 2023 also they have asked questions from ET curve and from the segregation model only. In 2022 also same kind of questions has been asked from ET curve, from segregation model. So these kind of things are very, very important, and this is not very simple, but again you have to do practice of all of these kind of questions. If you have practice a lot, definitely in the examination the questions will be very easy for you. Okay, I hope all of these questions now you get to know. And here I have completed the PYQ series of non-ideal reactor. I will be moving towards the next PYQ series of heterogeneous catalytic system, and after that I will be moving towards the solution thermodynamics also. So I am hoping till 31st Jan I will be able to complete most of the part of PYQ series of this gate chemical engineering. And my only request is that you just go and share my YouTube channel link with someone else who has not access of getting this kind of study, something like that. Okay, so they will get benefited. Okay, thank you and see you in the next lecture.